Alright guys, now we will do experiment 4, exercise 1, which is basically this one. Again, the first step. Actually, there's nothing special here. We just have one load, which is in newtons, and then I have my dimensions, which are in millimeters, so that is our units. The distance B here is actually 60 millimeter, and I have two hinges on this beam. The first one is here, the second one is here. This example looks much more complicated than what it is, so let's start. Now we go to our SAP, a new model. We'll change this to newtons and meters. Guys, never forget this step. Now when I do grid, I'm gonna have this window. At this point I will need to decide how many grids am I gonna have in the X direction. It really depends on you how we're gonna divide it, but to me I'm just gonna divide it every 10 millimeters because I think that's gonna be much easier to manage. Okay, now if I have here all the longest horizontal part is this one, which is 250 millimeters. So if I'm going to divide it by 10 millimeters, that means I'm gonna have 25 millimeters, or I'm sorry, 25 grid lines. Now, as I told you in class, we need to add one more. So whenever you come up with a grid line number, you just need to add one more to it. So 25 plus 1 is actually 26. In Y direction, I have nothing here. And in the Z direction, I have 1, 2, and 3, right? Now, this part is 60 millimeters, and this part is 75. So I cannot divide it by 30 or by 20. I actually can do 20, but I rather do 10 millimeters as well. So the total height is going to be 60 plus 75, that is 135 millimeters. And because I'm dividing every 10, I'm gonna need to make this one actually 80 millimeters because I'm not going 5 by 5. Okay, so 8 and 6, and I'm gonna add 1 for the datum here, so that's gonna be 15. In the X direction, I'm gonna do 10 millimeters for each grid, and the Y I have nothing. And the Z axis, I'm gonna do 10 millimeters as well. Now this is the biggest part of drawing your section. Okay, so you need to make sure that is correct. Again, we remove the 3D view. Now I need to change it to XZ, and I will start drawing my thing. This is a straight frame, so I'm gonna keep it a straight frame. I'm just gonna go from here to here, and you can barely see it. Wait, let me zoom out. You can see that the length is 250. That is good, that is exactly what I want. And then I'd go up by 60 because that is the height of B, and then I go to the right by 90, and I'll be done here. Now I'm gonna be facing another issue. Actually, it is two issues. The first one is this beam is curved. The other one is this beam goes 75 millimeters, okay? And my lines are divided by 10 millimeters, so I can never do it exactly. So the best solution, in my opinion, is we go to draw special joint and we place a point anywhere. Now I'll go to this point, and actually what am I gonna do is I'm gonna insert its location exactly. Okay, now I'll choose location, and then I will need to go to XYZ and double click. Now it's asking me, where do you want to place this dot? What I need is my distance from the x-axis is from this point to this point, but I don't know how much that is exactly. All I know is 250 minus 90 minus 75. So actually SAP is smart enough to do that for us. So 250 minus 90 minus 75, it's going to give me the answer. I have nothing on the z-axis, so I'm going to leave it in that way. In the z coordination or z coordinate, I'm going to need to go 60 then 75, so I'm going to do 60 plus 75. That is it. If I press OK, then OK, my dot is going to go exactly where I want it to be. Now what is left is for me to draw the line, the curved line. So to do that, I'm gonna press on draw frame or cable, which is what we usually do. But what is different here is I'm gonna come here and do curved frame, right? I'm gonna choose the starting point and the finish point. When I do that, this window should come up to you, okay? Now, I don't have all of these data. I don't have 3-point coordinations, but I do have a radius, which is 75. So I'm gonna change this. I'm gonna come here and go like planar point and radius. And now it gives me the option for radius. So I'm gonna go there and write 75 millimeters. Okay, and voila, we have our curve. Now the next step should be the supports. Now you can see that this support is pin support, and you can see that one is actually pin support as well. And that's what I'm gonna do. Support doesn't have define, it's automatically assigned, so I'm gonna go assign, and it's a joint and restrain. So I'll choose the first one, I'm gonna place it, and then I'm gonna say, look, this is pin support, and then I'm gonna choose the other one and tell him this is pin support as well. Now what you can see is that this support is actually not vertical, it's horizontal. Okay, so I'm gonna need to change the local axis for this support. I'm gonna need to rotate it. So doing that is really simple. All you have to do is select the support, go to assign, and we're just gonna work with a joint. So we'll go to joint and then local axes. To rotate the support in this y-axis, in this way, we will need to rotate it on the y-axis. So I'm just gonna write 90 because it's rotated by 90 degrees, and I'll do apply. If you look at it now, it looks right. The yellow one, sorry, the blue one is the vertical axis, and the red one is the horizontal axis. So to me it looks good. So that is what's necessary. Now there is another problem here. We can see that this member has hinges on both sides. So we are familiar with this. If I have hinges, then I'll simply select the frame and tell SAP 2000 like I have 2 hinges here. So how do I do that? It's simple as well. You go to assign. Now we are working with a frame, so we go to frame and then releases and partial fixity. Now we're gonna tell him that we don't want any moments on the 2-2 axis and no moments on the 3-3 axis. That is why we have zeros here, and then we press apply. The shape should change in this way. If that happens, that means it worked. Alright, so let's look back to our drawing. What is missing here? We need to apply the load, which is in newtons. Now loads require you to define first, so go define load pattern. I'm gonna call this one live, as in live. I'm gonna do live here, and then add new load pattern. If I see it here, that means it works, and this should be 0. Okay, now we define the load pattern. Now we need to tell the program where is the load and how much it is. We select it. If we look here, you can see that it's actually a joint load, it's not member load. So assign joint load, it's a force, and the load pattern is lie, and if we go to Z, it has to be negative 80, because for Z the positive is going upwards while the negative is going downwards. Okay, now if this said gravity, then the opposite is correct. Okay, so this is why you need to look at the drawing and the direction of the arrow just to make sure it's correct. We do apply, and there it is. I don't think you can see it, but I can see a silhouette of an arrow. Alright, so we did the load, we did the member, I did the support, and there's nothing else. Now I need to remind you that this member doesn't have a section. So what we're doing here is actually we're just choosing the default section. But just to be sure, I'm just gonna go assign frame section, and I'm gonna make sure that it is this. Now it is meant to do this automatically when we draw, but I just want to be sure here. That's about it really, guys. So if I do run, I'm gonna close the model and the dead, I don't need them, and I'll just keep the live one running. It's gonna ask me to save it. I'm gonna go to my folder, which I don't know where it is, to be honest, I'm sorry. So yeah, strength and material, strength, let me save it here. It's video experiment 4. Hey, I'll save it, and it's gonna run. Alright, now this is a deflection. The deflection doesn't look good. I mean, this body will simply fail. But again, this is just an example. If I want to see the axial loads or the reactions, I'm gonna go to the joints and I'll make sure that this is a lie, and you can choose arrow or tabulated. I believe I've never shown you tabulated, so this is a good opportunity. So F1 is negative 666.67, and the other one, actually this doesn't show well right now, so I'm just going to keep it as arrow. So I have horizontal forces that are equal each other, and these are my x-axis forces, sorry, vertical forces. Now I will need to see the moment. I need to know what is the maximum moment here. So these are the maximum moments. Now since this is a mess, the best choice is to right click on it, and you'll be able to see the maximum moments. On the first member is 20. On this member it is, that's a huge number, 20,000 Newton millimeter, and the maximum is at 54 millimeters. Deflection is kind of funny if you look at it, and it's really interesting. Now if you want to look at the shear force, again, we have been doing this for a while now. Apply, and this is the shear force, or the maximum shear force that we have. Since this is a cantilever, the shear force is going to be steady because we only have one force at the very end here, so it's going to be the same everywhere, and all of these results actually they make sense. Now let's do the second experiment now. So let's start a new one. So what are the units here? We have meters and I have kilonewton. So the units are going to be kilonewton meters, and I'm going to use the grid. Alright, now the real question is, how many grids am I going to have in each axis, and how long are they going to be? How far apart are they going to be? Now the thing is, from here to here is 10, and then from here to here is 8, right? So I will need to divide it in a way that, how do I explain it? You need to get a number that you can use to divide these members. Okay, so if I use 5 here, what's going to happen? The first section is going to be fine, right? I'm going to have 5 and then 5, and it's going to be well. But for the 8 meter part, I'm going to have an issue because I'm gonna go 5 and then 5. I'm just gonna be outside. I don't want that. So the best solution is to have 2 meters, right? Because 10 is divided by 2 meters and 8 is divided by 2, so that's gonna be fine for me. So how many am I gonna have now? This is 10, so divided by 2 is 5, and this is 8, divided by 2 is 4. Adding them up should give me 9, and I told you we'll always add one number, so it's going to be x, so it's going to be 10. Now in the z direction I'm going to have 2 lines, so they're just going to be 2. Y, again I have nothing. The gap between each grid is going to be 2 for the x, 1 for the y, and for the z is going to be 10 because they are 10 meters apart. I'm gonna start my section at 0, 0, 0. So press OK. I should get this. Close 3D. Go to YZ, and that should be well. Now, what I need to do is again we draw our line, and it says length equals 18. That is accurate. That is good. Now, after 10 meters, what I do have here is a cable, so I'm gonna need to draw that as well. So where is 10 actually? If you look at this point, it will show you when you reach 10. So this is 8 and this is 10. But first of all, I need to change the straight frame part. It's not a straight frame, it's just a cable. So I'll draw it from here to here. Now it's gonna show me this window. Now I'm not gonna change anything here because the defaults are good. I'll push OK, and I got my thing. Now I will need to add my supports, so I'm gonna go to assign, joint, restraints. This one is going to be fixed, and this one is going to be pinned. I'm also gonna have a support here that is pinned. You can look at this circle. Cables cannot be connected to roller support, so it's gonna be silly to think that this is a roller support. So it is pinned, and that's it. But again, similar to the previous problem, this is not in the correct direction. I need to flip it. So this is what I'm gonna do. I'm gonna choose it. I'm gonna go to assign, joint, local axis. I'm gonna flip it by 180. Press apply, and it works. This is exactly what I want. I want to make sure that this is the default section. So I'm gonna go to assign. I'm gonna go to frame section. I'm gonna say, look, this one is FSC. Apply. That is good. And I'm gonna do the same thing for the cable. I'm gonna choose it, and then I'm gonna go to assign, cable properties, and this is cable 1, by the way. That is good. Now what is left? I have my supports, and I have my members, and I have the only thing that is missing here is the UDL. So for the load, I'm just gonna go to define load pattern again. I'm gonna call this one live, and then I'm gonna call it live, and then I'm gonna add it, and we're done here. So how do I add UDL, or uniformly distributed load? It is really simple. You just choose the member, you go to assign, frame loads, it is distributed load, and I will need to change the load pattern to live. And pay attention, it says gravity here, right? So I'm not gonna need to put it as negative, it's just gonna be a value. What is the load here? If you look at the picture, it's 12 kilonewton meters, so just 12. Okay, the direction of the arrows makes sense, everything else makes sense, so I think we can run it. So let's do that. Run, turn this off, run now. I'm gonna call it B, save, and we can see that the shear force is coming in this way. Now this shear force makes sense actually, because the cable is a support, okay? So it will have a very strong or very big reaction, so it will affect my shear force diagram. If I go to if I want to see the moment, yep, it makes sense as well. It is going to the negative moment here, because again this part of the cable will act like a support for my beam, so that makes sense. You can see that the moment here is 0, and that is correct because I have a pin support here, and at pin supports the moment has to be 0, but this one is fixed, and you see we have a moment, so it makes sense. The last thing I need is the axle load or the reactions. Apply, and you can see that I have no reactions at x-axis, and I have 2 reactions here. So that is about it. Now if you have done this, then you have completed this exercise, and I think at this point we are very familiar with the process. Everything is repeated. The only extra thing we have here is that we have a cable, and in this part the only new thing we have is the curved part. Okay, yep, that's it. Alright, see you guys.